Okay, so for Jordan's group's bug, what they have is a sword spinning around when you hold the space bar. But what actually happens is that when you hold the space bar, the sword just kind of starts flashing and starts blinking around. So, first of all, it looks like it's something wrong with the camera, so we'll jump into like the initial init loop, and then we notice that there were two cameras in there. There was a camera 1 and a camera 2, which is kind of strange if you're just looking at one thing. So you go a little lower in, you see a camera 2 plus plus, which moves the pointer around. So like after the first frame, it doesn't point at the right values, and we jumped into that and we looked at the position after the second frame, and my assumption was right. The values of the position for camera 2, it's pointing at really big and really small numbers, which is kind of weird. So to fix this, we kind of just unified the two cameras into one camera, and then it ended up working because you're only updating one camera.
From Phil's group this week, we have a bug relating to an assert. So we take a look at the document. We see that we have an assert being hit when the game timer reaches a certain point. They don't intend their game to ever run for that long. They've sped it up for the purposes of this assignment so that it's actually hit in about 1 minute rather than the 30 minutes that's specified in the document, but that's fine. So they're aware of the assert, and when optimizations are on, when we're in release mode, the assert is gone, and they're not sure how to deal with that. So if I start taking a look at the code, I can spot the assert. We have this check function here, and what it does is it takes in a number, and it checks if incrementing that number by a large integer will make it less than the original number. So essentially what this is doing is it's checking if the number is close to overflowing and rolling over to, instead of going past the maximum because of how integers are represented, of course, it will flip over and it'll become close to the minimum number possible. And so that's their check, essentially, to see if the game timer is running too long. Now, what I want to do here is I want to replace this code with something that isn't an assert, because of course, like the document said, the assert isn't working in release mode. That's the whole point, right? So let's add some code that'll work in both modes. So I have here an if statement that will essentially check the same condition, as well as another flag to make sure that we only ask the user once. What we do is we pop up a message box if the same condition was true, and we ask the user explicitly whether or not they want to continue execution of the program. Now, the reason we have the directives here, the preprocessors for checking debug mode versus release mode, is simply because string formats can be represented differently in each of these modes, and to account for that and avoid compile errors, I needed to split up the two versions of the function call here in a message box, but they both do exactly the same thing. And so after the message box evaluates to the input from the user, we simply decide whether or not it's time to exit the program or continue onwards, which is exactly what the document wanted from us. So here we are again. We've got an obfuscator bug to solve. Was not happy to see another one of these hit my laptop, but we're going to tear through it, and it was a rather small one, which I was happy to see compared to the last one that we had to go through. So this one's from Tasso's group, and the expected output is that you send a command line argument, a string, and it'll output a small graphic of a keyboard representing which keys you would have had to press in order for that string to be created. So you can put a word like art, and you can put in maybe 2 A's if you want, 2 R's, 3 T's, but still you'll have a graphic of a keyboard with the A, R, and T pressed down. So I take a look at the code, I send in a command line argument through Visual Studio, and I try to run it. However, I'm getting a pointer error. And so some sort of memory is being violated. I'm not sure what's going on. Obviously, there's no way to really tell at a glance. So I get my whole team on this, and we each spend some time looking through it, and it takes a long time before we can find anything. And we try lots of different things. Of course, it doesn't work. Well, at that point, when we start getting frustrated, we have to sit back and we have to just write down really what we know about the program. And it was really that step that got us through this one. So we sat down, we said, what do we know? Well, we know it's a pointer error. Access, violation, reading location. That's all we know. But what does that really tell us, right? So we look through the program again with this vivid in our minds, and we see a couple sections where indexing is being used with the square brackets, and at the beginning we see a chart pointer. So now we have a bit of focus since we took that time to sit down. We start playing around with all of these. Eventually, we realize what the solution is, and we're playing around with the chart pointer, and we change it to a double pointer. We've seen a lot of double pointers in these obfuscator bugs, and that actually ended up being the fix that changed the program. Of course, it's pretty difficult to tell you why, but the whole point was that we had that moment where we sat back and we wrote down what we knew, and we were able to get through it. So even though it was a bit of trial and error, it worked out, and we have the output here, and you can see a whole bunch of different tests with different strings and the keyboard being represented as you would expect.
Alright, so this week we got a bug from Thomas's team, and the program is a simple application that draws a spinning monkey head, like in the picture here. However, the actual output is we're getting a runtime error shown here. So, what we do is we take a look at the program and we start from the beginning. So, we look in our main loop and go through the thread loop that is our first line, and we check to see if there's any issues with the rendering or any of the updating. And it turns out everything is good. Everything's all good to go with the main loop. So it must be some sort of issue with the threading. So I was pretty stuck here. So what I did was I looked up threading and how it worked in C++, and it turns out that the main thread is doing its thing in the loop while the actual second thread continues on and goes straight to return 0. So what this is doing is it is actually trying to clean up a lot of memory once it hits return 0 while the other thread is still functioning. So this causes a lot of memory issues, and that is what's going to be causing our crash. So how do we fix this? Well, after doing a bit of research on threading, I found that there was actually a function called join. So what join does is it takes our threads and it waits until the other threads are done executing what they're trying to complete. So that prevents us from trying to clean up memory after we hit return 0, and it actually fixes the problem that is happening here.